all the time. All right, man. So hey, we're in Windows reliability world again, and these are some of the people that have made Windows Vista a very reliable general purpose operating system. Introduce yourself. Who are you?
I'm Cornel Lupu. I'm the dev manager in the feedback team.
All right.
I'm Kinshuman. I'm a dev lead in the feedback team.
I'm Braunstein. I'm a program manager in the feedback team.
I'm Siamak Ahari. I'm the SDET lead for Windows Vista.
Software design engineer and test lead.
Yeah.
All right. So let's talk a little bit about the specific things you guys work on that help make Vista a more reliable system. But let's talk about reliability in general first. Like, define reliability for me.
Well, I guess reliability is pretty much what customers experience running your operating system day to day. And from their perspective, an operating system is reliable if it doesn't crash or hang or blue screen, or at least not as often as it becomes noticeable.
Sure.
So the interesting thing to note here is that the reliability of the operating system is something that real customers translate to much more than what we would consider the operating system. So to them, that the fact that, let's say, IE crashes or Adobe Acrobat crashes says something about the reliability of the whole ecosystem. I mean, there are many cases where people blame Windows for things that don't have, at least from our point of view, don't have much to do with operating system code.
Sure.
But the operating system is the thing that all the applications sit on top of. So its failures and its design flaws reflect into how well developers can go write code and how reliable that code is and so on.
Yeah.
Now, what we focused mostly during the Vista timeframe was to make sure that the components that are part of the operating system are very reliable and very resilient to failures. And at the same time, as Kinsh was going to talk about it a little later, trying to figure out a way that when something actually crashes or hangs, we have a very reliable way of detecting it. Some of this work that we and people before us have done in the previous operating systems, while it did a lot of good work to identify when something crashed, it came short on a number of types of crashes where, one application would basically die silently, or we never get to the point where we can capture what was wrong. Anyway, Kinshu should be able to give.
But I mean, that brings up an interesting question. I mean, let's talk about the physiology, if you will, of a dying application. So we all have had experiences, and I don't care if it's a Mac or even Linux. I mean, I've used various flavors of Linux and various flavors of Mac. Sometimes apps just disappear.
Wow.
The process dies. It's gone.
Right.
Yeah.
So, and then you're not, there's no prompt from the system going, well, in case you didn't notice, the app you were just using is now gone.
Right.
So, it's hard for an operating system to be able to know what happened, but it could have been the operating system's fault. Now, those types of errors could actually be an operating system level error when a process just all of a sudden evaporates.
So as you know, like the operating system has user mode components and kernel mode components. So when you encounter a problem, you pretty much cannot trust anything that is in user mode. So you can say, well, I'm running code, but I have experienced a crash. The more code you try to run in that state, the more probability is that the system can go into a much more worse state from which it cannot do pretty much anything. So you mentioned that the process just silently went away. Most likely it was trying to do something, trying to tell you that it's crashing, but it's in such a bad state that it cannot do even that. And as it goes that path of self-destruction, finally the OS will say, you are just a dead guy now. You should just go and die. And that is when the OS silently kills the process, because it is not in a state where it can do anything. So we did a lot of work in Vista actually to determine how we can report for these cases. So can I use the board? Let's draw some.
Of course, I love it when we do board work. I mean, that's what it's all about, man. That's why there's whiteboards in every office.
Yeah.
So let's say that this is user mode, right?
Mm-hmm.
This is untrusted territory when problems happen, and this is kernel mode. Kernel mode is fairly trusted, although if you have bad drivers, then it also becomes untrusted, but it is like fairly trusted. Now here you have an application that is actually running in user mode, and it actually, suppose this is all this code that is running, it's a thread which has user mode and kernel mode parts.
Mm-hmm.
It actually encounters a problem while running some code here, right?
Okay.
Now, the way normally any information that actually you want to convey to the user that a problem has happened happens in user mode. So you basically are trying to run code in a process that actually already has encountered a crash, right?
Okay.
So it's not in a stable state. You're trying to make a dead guy pretty much more or less say something, right?
Uh-huh.
He can do some stuff, but he's not in a reliable state. So the way crash reporting used to work earlier before Vista was, we tried to run all the crash reporting code directly from user mode. Now, as you can see that we are trying to run a lot of code inside a process that's no longer in a trusted state, right? So as it tries to run code here, it can actually encounter some fault that might have caused the original crash in the first place.
Mm-hmm.
So if you try to actually go that path, it's going to crash again and again and again, and finally the OS will say that you are not in a state that you can run any code, and the OS will kill the process from the kernel mode. So that is the scenario where actually see, while the process crashed, you don't see anything because it's trying to tell you something, and finally it is killed from kernel.
Okay.
So basically it is kind of like, how much can you trust the process when it has already crashed? And the answer is you cannot actually trust it anything. You cannot trust the process to do anything once it has crashed.
Sure.
So what we want to do in this case is pretty much, once it crashes, we don't want to run any code in the bad state. We want to go in a state that is now safe, which is kernel, right?
Okay.
So it crashes, it goes to the kernel mode. We don't allow it to run any code in user mode. We basically, from the kernel, hypothetically you can say that we actually start a new process, right?
Mm-hmm.
So it does not actually start a process. It tells the already running process that, hey, this process has crashed. So imagine this is PID 10 with some thread ID 20 or something like that. It passes that information back to this already running process 1020 and some other parameters. Now this process, which is in a healthy state, it knows that this process has crashed. So this process will do the error reporting instead of error reporting starting from within this process. And as you can see now that this is in a pretty healthy state, and it can actually do any error reporting that
Excellent.
this guy was not able to do.
And so this will explain, like in Vista, where you can reliably receive the, Internet Explorer has stopped working,
Right.
or Internet Explorer has stopped responding.
Yes.
And I don't mean to pick on Internet Explorer, any kind of user mode application. And so in XP, and I want to make it clear, that wasn't the case.
Right.
XP, Adobe Acrobat would just go away.
Right.
And when it got to such a state where the operating system was like, "Hey, you're out of here."
There are many such scenarios. One of the largest category of crashes we are seeing in Vista is for loader-related issues. That's one of the largest category. And
Which one is that again?
Loader-related issues.
Loader, okay.
Loader crashes. Stack exhaustion is another category, and we're not able to get any of that data earlier. So now developers can actually get this information before the OS ships. They can fix those issues, and they can actually, it improves the reliability of the operating system because it's a new category of problems we're catching.
That's awesome. Well, great job, you guys. I mean, so it's an architectural change in the reliability
Yes.
subsystem.
It's a core architecture change, how the exception dispatching actually entirely works. And we have been able to make really good benefit of this architecture by tying this with how the debugger works, because we can actually now start the debugger in the same reliable fashion, and actually processes can be debugged even more reliably.
Excellent. So now, as a PM, you guys typically are in charge of the visionary sort of aspect of things, if you will, right? You think about it. So let's why don't you talk a little bit about from the Vista point of view, what did you set out to achieve for reliability in the components that you own?
Well, well, it's not perfect. I think that the experience when a user encounters a problem, any problem in general, has gotten better by leaps and bounds in Vista. It's basically I'm a user day to day using the machine. I have a problem, whether it's a crash or a hang or a freeze or anything else, and what is my experience when I encounter that and after I encounter that, and how has that gotten better. And that's something that I think we've done a ton of work in Vista. In XP, the experience is basically either the app will go away, as was mentioned, or sometimes you'll get the send, don't send dialogue that I'm sure everyone's familiar with, the little box. And a lot of research that we have done showed that users were very confused by that dialogue. A lot of the time, the user basically didn't see what the benefit was to them for clicking send. I've had people tell me, oh, I never send that thing. My friends tell me not to send that thing. It came up in class the other day and the professor just dismissed it, all kinds of stories. And so one big thing that we have pushed for in Vista is the solution aspect of reliability. In that, we have this infrastructure for collecting information about crashes and hangs and other problems. We have people here at Microsoft every day driving these issues with the product teams, coming up with fixes, publishing those fixes. So users are frequently shocked to learn that Microsoft actually has updates and fixes and patches and information that can help them prevent these problems in the future. And so we updated our user experience so that when a problem happens, you don't just see a send, don't send box. What you do see is, most of the time, it will automatically check for a solution to this problem. And if a solution is available, it will pop up right there on the screen. Yeah. You'll see a little notification, or if you don't want to handle it right now, it'll go to the control panel and you can drill in later. And that's another part of the UI experience that we improved is a user can go to the control panel at any time. They can see the history of all the problems that have happened on their machine. They can see if any new solutions are available for those problems now. If they have any fixes that can be applied right now, they can, with one click, update them if they happen to be available on Windows Update, or if they're for third parties, they can see that information as well. They can drill into the details of any issue. If you're a developer and you want to debug an issue, you can see the dump files that are attached to a particular report. So we've provided a lot of user experience improvements here that were never available in XP. A lot for administrators to be able to control what data goes off the boxes in their set of machines, and for home users to basically be able to get access to a fix or solution or workaround and be able to prevent problems from happening again.
Excellent. Well, and clearly the infrastructure of Vista has enabled this experience, because Vista is a user-centric OS from the core. The architecture is re-architected to be more user-centric, not just throw a bunch of new UI on it and make it more user-centric, but it actually works with the user in mind at very low levels, popping up meaningful dialogues and helping the user. And I interviewed the diagnostics team recently, and they actually, many of the errors can be caught and fixed automatically. So some system errors will be caught and fixed automatically, and the user won't even know it ever happened. So you get to try to break all this stuff, right?
Right, I'm the one
You guys go, oh yeah, so that's the new architecture, huh? All
exactly.
Right. So what did you do? What do you do in this world as a tester?
Yeah, the goal was, I think, for Vista, the vision was to close the loop and basically make sure that we could fix these errors and improve the experience overall. And so we added a lot of new features over XP. And in order to see how they work, basically my goal was to try to come up with different ways of having processes dying. So our goal was to see the don't send dialogue. And in that now in Vista we improved all of that and actually have the customer in mind and see how the flow is for them.
Sure.
As I said, come up with different ways of breaking everything.
Yeah, that's cool. Well, good job, man.
So one thing that I want to add to this is that the error reporting that we have on the client is really just the tip of the iceberg, and the iceberg really is the whole feedback loop that we've built, and there's a huge amount of investment on the back ends. We have a technology called Watson internally that we use to basically get all this data in a way that is we are able to prioritize what things happen with the highest frequency and use that to drive improvements in the engineering process. And one thing that we did during the Vista development time was basically to enhance our engineering and how do we address these problems, crashes, hangs, blue screens. We've spent a lot of effort in making sure that we have some sort of a push model, that when there's a tremendous amount of data coming through this Watson loop, but traditionally the Windows organization has been trained to work in some sort of a pool model, that the data is available there. If you want to go and find the data, you can go and mine and find out what was happening with your components and so on. The other thing that was a little difficult was that the way Watson has been designed, it works reasonably well with an environment that is relatively stable. So once we ship a product, then we do a pretty good job at creating signatures for problems such that one problem maps well to all the people that are encountering that problem. So to say that in different words, if 100 people are hitting a specific problem that is a bug in your code, we are able to create one signature for all these people. All of them will submit the same signature. That is critical to how Watson works, because that's the only way that we can count and say that this particular problem happened 1,000,000 times versus this other problem that happened only 100 times, right? So it gives that kind of weight to development teams to focus their efforts in fixing the problem. Coming back to what I was saying, one important thing that we did in Vista was we changed a little bit this model of, instead of having people go to fetch the data, we made it a little easier, and we identified what data needs to be delivered to what development team, and we did it in a push model. So we were basically embedding it into other engineering tools, such as like Product Studio, that we use day to day. This is like a tool that every developer in Windows, you have IE and Product Studio open, among other things. So having that kind of integration with the rest of the engineering tools that we use on a daily basis was, I believe, an important step in blending all these technologies into the typical development process in Windows.
Absolutely. I mean, that brings up a good point, because in reality, these Watson reports, go from the machine to a dev's inbox, being a product studio. You've got bugs. Somebody has to do a little bit of the work, but the instrumentation in the system and the instrumentation in here at Microsoft in our system has been really fine-tuned, so that an error happens, in some way it finds its way back to the right developer who owns the feature, and then that developer and the tester that he or she works with will figure it out.
And also we have one other thing that we worked a lot on in Vista was to basically try to get as much information as possible about the state of the crash process.
Yeah.
Because it became apparent that when you're trying to debug the problem, the developers needed more data about the process, about the state that it was in. And one other things that we did, among other things, was to give the ability to collect as much data as possible about the process and the state that it was in.
Cool.
And through that we were able to basically make Vista a lot more reliable and to get bugs fixed a lot faster during the beta phase. I don't know. I don't think we have the stat, but the numbers of bugs that got fixed because of the new data collection things that we added were
true. Well, that's a great segue, because that's what I was going to ask next. Was I heard, and I know, because I work here,
right.
But I heard that Vista actually does a much better job now of collecting a lot more data per crash, and not just what state was the app in, but what state was the kernel in.
Right.
What state was its dependent DLLs in?
Right.
Because of course we understand dependencies a lot better now in Vista.
Right, so I think there are two important things here. First is like how well can we categorize problems, right? So earlier we used to have this problem, well, this is an unknown category. We don't know that like, which module to blame. So we just say it's unknown. So we have made a lot of improvements. We can actually now find out, well, this crash happened because although there is no DLL loaded, it's an unloaded DLL. We keep track of DLLs that get unloaded. So we can now actually blame that guy and say, well, the crash happened because this DLL got unloaded. And we can also find out, well, SVC host crash. SVC host is a process that loads many different services. So now we have the technology to actually find out which service inside the host crashed, instead of just saying that SVC host crashed. And even in the UI, we can tell when the crash reporting UI comes up, we can say whose service crashed, instead of just saying generic host for services crashed.
Excellent.
So and there are a lot of other improvements around that area. For example, now we can say, well, we do not know which module to blame, but we can take a stack hash of the stack itself, and that way we can try to differentiate problems. So we have done a lot of work in trying to identify problems into separate categories, which actually is a key thing when you try to find out which issues customers are hitting the most.
Excellent.
The thing that I would like to add to that is that specifically in Hangs, so with Hangs and XP, we had a very, very tough time. We weren't able to actually get to the point where we can categorize Hangs appropriately, right? So pretty much everything was falling into one bucket, and the amount of work that we done in XP and the kind of features that we added were specifically targeted towards what Kinshu was mentioning. So we were able to get to the point where if an application is hung because there's something in the kernel that is not responding, we are able to actually pick up a live kernel dump to go along with the user mode stuff that we would send for that application. We have the ability to say that this application is hung, but it's because it's talking to this other application, and we can actually go through the error reporting mechanism, fetch a memory dump from other applications that are involved in a cluster dump, I guess.
Sure.
So there's a bunch of these kinds of capabilities that we've added that targeted specifically our ability to identify the root cause. We've added things like fetching certain type of data from the kernel, a lot of it user related. By user I mean the window manager, where we can actually, so this is very valuable for hangs, right? There's tons of hangs that happen because of messages going between windows, things of that nature. So there's certain class of data that is super important when it comes time to debugging these kinds of issues. So we've identified that problem, and we said, well, we need to fetch that kind of data as well. And there was some cross-group work that had to be done there in order to get other teams as well to participate in this effort.
So that brings up a good question. I asked Mario this question too. You all know Mario. He
Yes.
used to be the leader of the reliability team. So how would you define a hang? What's a hang? What's a hang? What is a hang?
Well,
it's a hard problem, isn't it?
It is very hard. We kind of, I think the way we categorize it, we divide it into the app that has the UI or user interface, the window user interface in there, or there's an app which doesn't have that. And in Vista, I think we can detect a hang for those apps with Windows and UI very easily. Because of the way they process their messages, and if they stop processing the messages that the Windows sends to then we know it's hung.
Okay.
And as Cornel said, the work that was done on that area is tremendous. I think we have even thread chasing capability, so we can even pinpoint the thread that's kind of hung.
Thread chasers.
Yeah,
Be a good name for a band, man. All right.
And then we have the other ones without the UI, which is a bit trickier because there's kind of at Vista kind of, or at this point we kind of can't track exactly. We can't automatically detect the hang, and there's some interface required from the user to say, okay, it's hung, and then we get involved, and then
even
we
when
can
they do,
pinpoint the
even when they do have UI, the big challenge with hangs, I think, is there's always a possibility that the app could come back on its own. You never are sure. I mean, you can make good guesses, but the problem with hangs is all you know is that the app hasn't responded or the process hasn't responded in N amount of time.
Cool.
And so you have to sort of make best guesses a lot of the time as far as is this thing hung, and of course you can tell if the user's clicking on the red X over and over again, then it's
Sure.
most likely hung.
But let me interject just one quick question though. Let's be honest. I mean, writing multi-threaded applications isn't easy on Windows, isn't easy on Linux, isn't easy on any modern operating system. It's not an easy thing to do.
Okay.
So, you know, without mentioning names of applications, I mean, every single day I'll launch an application and I'll try to do something which I should be able to do because it works in an offline state, but I can't because it's trying to do something else. I will get the not responding sort of thing in Windows now. Who owns that? The desktop Windows manager? Who owns telling me that it's actually hanging?
So I can tell you a little bit about the history there.
Because they need to get it right, but I mean, I'm just kidding.
Right,
It's a
so
hard problem.
the first operating system that actually, the first version of the Windows operating system that had that kind of support was Windows 2000. And the component that actually is responsible with the detection of the fact that an application is not responding, as well as displaying the not responding, is the window manager. So it was up until Vista, it was kind of like deep down in the kernel in win32k.sys, where this detection happened. And Siamak was saying the definition of a hang from the operating system perspective, meaning the stuff that we detect automatically, is that the application didn't process its input messages for about in the last 5 seconds.
Okay.
Right, so it's not something very flexible. Why 5 seconds? You know, more historical reasons. So.
Okay.
Now, that detection happens, and what happens in win32k.sys is you get to see that not responding on the caption. Really what happens is that there's actually another window that is displayed exactly where the hung window was. The hung window is actually made invisible, and this allows people to move the window around. So a window that shows not responding, you could still move it around, you could minimize it, you can still do work if it interfered with some other applications, right?
Sure.
Now in the past, like before having this feature, when an application was hung and not responding, you couldn't even move it around, you couldn't resize it, minimize, none of that, it would just take real estate. Now in Vista, some of that changed, and some of it changed because of architectural changes that have happened around the same area. So for example, DWM, the new desktop window manager that is outside of the kernel, and it allows us to do all this cool stuff, you know, arrow and desktop
Flip 3D
composition,
and
right,
all that
flip
stuff,
3D and all that stuff. So some of the detection is still in the guts of the OS, but what do we do with it once it's detected has moved now to the desktop window manager. But again, it's really arbitrary. We got a lot of feedback during the development of Vista from people that said, well, why the 5 seconds? Why don't we adapt? For example, if an application was indeed poorly written, but it's one of these applications that always seem to come back, right? So it is hung, but temporarily. It takes it, let's say, 8 seconds or 10 seconds to do its job, and then it comes back. Why would Vista be so aggressive and put not responding, and all of a sudden nothing, you know, seems very responsive? And that was also because some of our handling of this feature during the early Vista days was a little bit too aggressive. So what we would do is when we would detect that the application is not responding for about 5 seconds, we would go and frost the app so it would look really like milky or something like that. And then everybody was like, oh, all of a sudden like things become so much more unresponsive in Vista. Everything is milky after a while.
I remember that. Early in the phase. It was like beta 1 or something.
Right. So obviously there were many things that contributed to it. Some of it were actually bugs in Vista. Some of them were performance issues. A lot of it were application problems, right?
Sure.
But now we're not as aggressive, right? So while that not responding thing still shows up, so that you can still do something about that app and move it around and minimize it and stuff like that, we're not as aggressive in the UI effects that gives the people impression that, well, for some reason things are really not that responsive.
So one thing that I will add is that a lot of work has been done to find out how UI applications are hanging. We have started some work in finding out how services and non-interactive processes are hanging, but that's a really tough and challenging area, and that's a question I asked in the interviews, hoping to find out if somebody has nice answers.
So you asked that in job interviews?
Yes, unless
Oh, you gave that away, man. Oh, that's cool.
Well, if somebody has an answer, I'd like to know. It's an open-ended problem. So we did actually in Vista, the service control manager actually monitors if a service is responding to control messages or not. And if it does not respond in a timely fashion, then the service control manager assumes it is hung, and we create a report for that. But there's a lot of work to make that feature more reliable and work in a nice way.
Sure, but let's talk about that. I mean, the reason that it's a hard problem for a non-interactive service. Which, I mean, it's non-interactive, so if you can't interact with it,
right,
how are you going to probe it?
Exactly. So the thing is, like, how do you define if it's hung or just waiting for something to happen if you don't know what the application is doing? So that's the challenge there.
Yeah, that's a hard problem.
That's the challenge, yeah.
Excellent. But I'm sure you guys will figure it out.
Obviously.
Well, so kind of like what I was saying earlier, we got a lot of feedback during Vista from people saying that we should be more adaptive in how do we detect that an application is hung. So things like, well, if we do see that an application doesn't process messages for 5 seconds, and let's say the user doesn't take any action, but then it comes back 3 seconds later, so it looks like a better delta for this application, a better timeout would be, let's say, 10 seconds, right? So that, we debated about that a little bit, and then we said, well, it's probably a good thing to keep the architecture of hang detection relatively clean and simple, and not overly complicated, such that we cause even more problems with what we do, as opposed to the problems that exist with applications out there.
Absolutely. But I mean, you have to, in the defense of application developers, I mean, we only they hit one thread. They get one UI thread to screw up.
Right.
And that's a fundamental
constraint,
architectural constraint
right,
that they're given, and that's why sometimes applications will become unresponsive. And it's hard for you guys to know what's going on. Is it making a synchronous web request to check email? Your guys aren't going to know that.
Yeah, actually, the problem is even more complex than that. So it's if you were to come up with like a prescriptive guideline of what APIs should you not use on your UI thread because they may be taking a long time, that list keeps growing all the time, right? So even things that you don't, there are some things that are relatively obvious, right? Like, I don't know, if you deal with, create file APIs, let's say, and you're dealing with files over the network, well, that's a pretty obvious scenario. But there are other things that are not that obvious, right? Maybe you do have to deal with some file on your hard drive, and you would think that you get like pretty good response, but then it turns out that that's something that is encrypted, and all of a sudden has to talk to other processes. So a lot more components of the system may get involved on something that may seem pretty benign, I guess.
True.
So even though, let's say, 5 years ago you designed your application and you tested it and it looked pretty responsive, that doesn't necessarily mean that the system itself is not going to change a couple of revisions later.
Sure.
And all of a sudden things become less responsive. And we're easy to go and blame the app developer, saying that, well, they didn't design it well in the first place. But the truth is that they optimized for simplicity, and they tested it at the time, and it was functioning, in the design parameters. But the system evolves, and one of the benefits and one of the reasons Windows is so successful is that we have a huge amount of applications that run on this operating system, and with every single release we try to keep that list as long as possible.
Sure.
We know that we break applications with every single release, but still there are applications that have been designed for Win95 that still work in Vista.
Absolutely.
And the kind of constraints and the kind of design decisions that those people made,
Way
8,
back
10
then.
years,
Yeah.
way back when, it looked very reasonable to them.
Absolutely. So, I mean, is Vista more reliable than XP? Hey, that's a question for you.
Well, I think
I mean-
that, well, we believe it is.
Okay.
We certainly put a lot more effort into at least measuring that reliability and making sure that developers know about the points where things have been unreliable and they go and address it. But I think time will tell, really. I mean, we really hope so. Windows is a huge ecosystem, right? And even the reliability of Windows and the ecosystem are things that evolve. At the beginning, when we come up with a new version of the operating system, there's a lot of things that need to happen in the ecosystem to bring that reliability out, right? There's tons of drivers that are still not available for the new operating system. There are applications that need to go through certain revisions and so on. So, probably the first few months, maybe 6 months, things are looking not that great. But then, after that, the ecosystem has a tendency of like self-healing.
Sure.
We truly believe that it is more reliable. It's certainly more reliable than what XP was at the time that we shipped. We compared ourselves with XP SP2. Every time we go and measure the reliability of Vista, we try to compare ourselves with XP SP2, which is a much more mature version of XP, right?
Absolutely.
It doesn't compare at all with what XP was at the time that it shipped. So we set for ourselves a higher bar that we're comparing against. But then again, as I said, like the ecosystem is huge, so the numbers that we have may not necessarily translate well with what we see in the wild. But I'm pretty confident that 4-6 months after Vista is out, right? It's already out. Things are going to be much better.
Absolutely. All right.
So one thing to add was, as Cornel shared initially in the beginning, that reliability is a perception of user, right? So we can actually make the OS very reliable. It does not crash at all in Explorer and IE native code. But a lot of these processes have plug-in models, right? Like, you might be running some add-in in Explorer or IE. And even if that is crashing, it actually destroys users' perception of how reliable the OS is. So we do have efforts that, to engage with ISVs, we actually monitor crashes in third-party components as well, and we actually try to sync with them and help them fix their bugs. Because as long as we do not actually have an ecosystem perspective of, how things are working, we will not really make a dent in how the users think that the OS is reliable or not.
Absolutely.
I think that at the end of the day, reliability has a lot to do with uptime. It has a lot to do with, first of all, not experiencing problems in the first place, and then when I do experience a problem, how quickly am I able to get back to what I'm doing, and how frequently am I going to encounter that problem again in the future. And I think with respect to those, we have so many new features in Vista that are designed to improve those that it's gotten significantly improved over XP. I know that just in terms of the number of things that we fix before we ship, the experience when a user does hit a problem, and then the ability to get fixes to those problems back to the user so they don't happen again, I think are measurably improved over XP.
So one thing that I would like to add is that in XP the way we looked at errors was basically crashes and hangs and blue screens, and in Vista we actually take a much more broader look at what an error really means. So for example, if an application is not compatible, right, is that an error or not? It is an error that we should know about, and all these cases are actually now hooked up with the error reporting platform we have. So non-compatible applications will actually also send error reports. We will analyze them and we'll be able to tell the user how to fix it. Same for issues like if a driver is not available, it actually impacts the customer's notion of how the operating system is behaving with him, right? So we actually have all these technologies now that we actually have extended to other problem areas, not only crashes and hangs, because although they are the largest factors how users see reliability, but they are not the only ones.
True, and I mean one of the things about we mentioned earlier about you being able to reliably capture data for an app that really isn't working anymore.
Exactly.
So there's a difference between this app is not responding to this app stopped working.
Right.
Right.
Exactly.
You have two new UIs now.
Exactly.
And you're typically always right when you're on the stop working side.
Well, we haven't tried on
I
this
said
one.
typically.
So,
But I mean, that is a good. That is a good point, right? Because you guys, you know that something stops working
right.
because either A, you can't communicate with it anymore, and B, some exception was, it threw some exception
yeah.
and the system caught.
Right.
Yes?
Yeah.
Okay.
But
So-
also, the other thing you think, as far as being as reliable as XP is, we have the data that says Vista is as good as XP-SP2 and even better in some areas. But these features that we add will help us to diagnose those problems and come with the fixes a lot faster on Vista. And also, the other part that we improved a lot is, I think it kind of dropped, is like in most of the crashes, but now we can recover your data. So if you're working on your Word application right now, if the stops working, then we built in this technology in there so that you can go back and recover your data. I thought Word had that before, it wasn't as reliable.
Sure.
Now in Vista, it's a lot more reliable, and we extended this to all the other apps, so that everybody, all the third-party apps out there can go and use this recovery mechanism. So if
awesome.
this happens, we
Yeah.
can go back and recover your data, and from the data that we generate, and with the use of the solution ERC, which is called
Problem
report solutions,
Yeah.
we can come back with a solution as fast as possible and
That's
get
awesome.
that fixed. Right.
One thing to add to that is Siamak mentioned third parties, and I think another big thing about Vista is the public API that we provide for error reporting that allows. I think it's much easier in Vista as compared to XP for a third-party developer who's writing an application on Vista to customize their error reporting experience to get information about the problems that are happening on their application from users and get fixes back to those users through Microsoft.
Absolutely. And I know there's a place on MSDN where
Yes.
actually I can go and find error reports from my app, and you guys will give me some incredibly detailed information that I'll use in my debugger. I mean, in my my development environment to try to find the bug, and that's hugely cool.
So one more area that we have invested in Vista is actually how we can tie up diagnostics with error reporting. So we know that there are many categories of problems. After the crashes happen, we cannot actually get meaningful data because a crash happened because of some bad thing that happened much earlier. So in Vista, we have capabilities that once we have those problems, we can actually ask the user to run the process in a certain diagnostic mode, so that the next time the problem happens, the dump or the state that we'll capture will actually pinpoint the exact problem instead of just saying later on that something bad happened earlier.
Excellent.
And that's an area we'll be investing in the future as well, because we really need to have very cool diagnostics to capture problems.
Totally. And in the end, it'll help Vista itself mature like SP, SP2. I mean, when you think about the dependency mapping that goes on in the system, that's also something. We'll probably touch on that more specifically in another video. But so Vista it'll evolve over time without a new version coming out, right? You'll be able to send down updates to fix problems a lot faster, because you'll know exactly what the problems are, and that's all goodness.
Right.
It's greatness. Plus, we moved a lot of stuff out of the kernel.
Well,
Right.
we moved a lot of the stuff out of the user mode. That stuff that we used to run in the user mode of the application that was dying, now through kernel is launched into a healthy process, and that process basically is kind of like a doctor trying to pick the pieces of what is actually wrong.
Architecturally, I meant we took the audio drivers, stuck them up in user mode.
Right.
So we moved, because as you were saying, when things go wrong in kernel land, things go wrong for everybody.
Right.
Right. It's like somebody does something bad in class and everyone gets punished.
Right.
Now it's more targeted.
Right, so some of that work in the user mode driver framework have a lot to do with improving the reliability of the system from an architecture level, right? Where they say, things that shouldn't be in kernel mode, that things that could actually easily run in user mode shouldn't live in kernel mode. And that's what the user mode driver framework has been able to accomplish.
Absolutely.
In Vista.
And all this stuff works in concert, right? I mean,
Yes.
you're all in the same. Windows is a big,
Yep.
you know, it's a big thing, and you guys are all, and reliability is like security. I mean, it's a big thing to say Windows reliability,
Right.
right? And developers have to learn how to write reliable code.
Right. It's one of the things that impact the most are the customer satisfaction, right? And, reliability and security and
Totally.
to some degree compatibility are super important.
Sure. I mean, in the end, and Mario really said it well when he interviewed. I mean, the whole idea is don't disrupt
Exactly.
the customer.
Right.
I'm trying to do something on this computer. Don't disrupt me. Now the UAC team, who I love, because I had them on soon, are experiencing the wrath of the customer because of the new notion that you run Vista as a standard user.
Yeah.
The days of running as admin are gone. You are a standard user. Sometimes you have to elevate, and the way that you tell the user this elevation is happening is you pop up some UI. So there's interesting things going on, but I still give them a lot of props for trying to solve a hard problem. And hopefully you guys won't get yelled at like, why am I seeing all these prompts, man?
Well, it's better than XP, so
You get-
already it's fewer prompts.
And we have the opportunity. The user has the opportunity to not to see any of that. So we ask them, "Do you want us to ask you this question again?" And they can say no, just send it, or just don't send it.
They can
I'm-
choose how
yeah.
much data they want to send if they just want to check for solution, or if they want to be able to send mini dump files or whatever automatically, then we won't bug them again.
That's cool. That's what I do, because I always want you guys to get the errors so they get fixed faster.
You're very trusting.
I am very trusting. Well, no, let's be important though. That's a very good point. They're serious. You get
Privacy.
nothing from my machine
Exactly.
that I would ever be concerned about you getting.
Right.
I mean, that's
Right.
that's not something that I worry about.
And
You don't know what files are on my machine, for example. That has nothing to do with what you're
That's
interested in.
definitely
true.
You want to know the state of the system.
Right.
Yeah.
And the data is also, it's kept in a secure location. It's not that everybody can take a look at that. Only people who have to take a look, have a business need, actually take
Yeah.
a look.
So even data that you agree to send that may contain personal identifiable information is actually, as Kinshu said, kept pretty securely.
Yeah,
Yeah.
we have privacy policies plastered all over our UI.
Sure.
And they're all available online, and they're very specific about what kinds of data we can collect and what it's used for. And as Cornel mentioned, we only collect what we think we will need to resolve an issue, and if we ever collect any data from you, it can only be used to resolve an issue. We can't, any information we collect, no matter what it is only used for
Understood.
debugging.
So for all the paranoid people out there, and maybe I'm one of them. That's cool.
It's
Send it. I send it. I don't care. I mean, fix the system, make the system better. It'll help me in the end, make it reliable for everybody. So that's good stuff. And you guys are the people that I just want. I'm going to pan around here again, because you guys are some of the people that when they say send data,
So
it ends up in your inbox,
That's
man.
right.
Change it.
These guys are writing code to fix it.
it.
That's excellent.
one thing I'd like to add is that,
Uh-huh.
basically the reports that we get actually help us in prioritizing which issues are important. So if people don't send us reports, we'll not know this is the issue that people are hitting a lot. So the number is very important for
It's
us to
like your
find
vote.
out. It's like a vote. If you don't send the report, you are not voting for us to fix it. And if you send the report, then you're voting to fix it.
Well, that's a
Everyone
good
knows-
idea. Hey,
Everyone knows how
PM
important
guy.
it is to vote, right?
Well, hey, why don't you make it more explicit, right? Vote to fix this,
exactly.
as
Well,
opposed to would you like to send this information to Microsoft?
and that's a lot
Vote
of
to
what,
get this thing fixed,
That's
man.
a lot of what we try to do in Vista, is to try and change it from just send a report because it doesn't really express any value to the user to there might actually be a solution to this if you search, if you look for this, and if there isn't a solution, we will try to find one for you. So
Cool, excellent, you guys. Well, hey, thank you very much for spending so many years working on Vista. We can't talk about it, and we're not going to, but maybe we will in a little while. But I know you guys are working on other things now, and things are just going to continue to get much more interesting
exciting things.
as operating systems continue to evolve. So thank you very much, and hopefully you're not going to get too many bugs to fix.
Thank you.
Thank you.